Yeah, my name's George Blundell. I'm solutions engineer at Curiosity Software for the past 5 or 6 years now. I've been implementing model-based solutions, so whether that's in the more requirement space or in more sort of test and test data space. So to start with, I'm going to set out some of the problems that we've seen with trying to scale automation traditionally, whether that be through sort of manual coding. And then I'm going to introduce some potential solutions. So look at some kind of real examples from some different organizations as well. So the main problem we're going to discuss today is all around the combinatorial explosion and understanding the mountain to climb. Test code is great. There's so many good standards out there. We had a talk earlier about making your tests atomic. All of that's fine. However, scaling is the challenge. Interesting statistics from the World Quality Report actually say that an average of between 15 and 20% of tests are being automated, with the remaining 80% being manual, which feels kind of crazy to me, especially now, 2023. Actually, that figure hasn't really changed in the past 5 or 10 years. So why is that? There could be a couple of reasons. I mean, the easy one to say is maybe teams that are saying they're doing agile and following safe practices aren't really achieving it. Alternatively, it could just be that software is growing exponentially. There's basically too many combinations, too much application complexity for us to even be able to get close with our automation script. So let's kind of tie that to a real scenario. Let's imagine you've got a big application, 10,000 functional test cases. We'll think about mobile testing in this example. How many different mobile devices are there out there? Followed by browser combinations, device features, localization, network, interruptions, and then different app stores. As we move along that sort of pipeline there, we're adding more and more complexity at every single step. And so basically, we end up with the issue of combinatorial explosion, i.e. there are now essentially billions of different ways that any given user can interact with the whole sort of ecosystem. Now, our gentleman here is basically our automation engineer in this scenario. He's essentially now trying to push the ball up the mountain of the amount of manual and essentially untested features that he has. So actually, if we think about the 80-20 ratio in terms of the manual versus automation, at the bottom of the mountain there, you can see we're kind of covering some of what some of the application behavior with automation. However, as we move between sprints, that mountain keeps on growing. You keep adding new features, complexity grows. And actually, a big part of this is actually how can you maintain those existing tests. So you really need help from the three amigos. You need to have automation that is componentized, reusable, and uses combinatorial methods to generate it. Really what we're saying is that however good your test code is, it's always going to struggle to scale the sheer amount of complexity that you have in your systems. And what we're really trying to avoid here is a situation like this, where essentially we've got, at the top there, we've got our requirements, which, well, in the requirements, that's where most bugs come from. Often, requirement dev test, all kind of siloed, not a whole lot of communication between them. So those bugs essentially now come through into the developed system. As soon as they do that, they become much more expensive to resolve. They multiply and get worse, and they also create rework and delays. And then by the time it gets through to test, that's when all the bugs, or some of the bugs, are actually being picked up. However, that's the most expensive part. And even some of those bugs will get through into release, and nobody wants bugs in their applications. So what I'm going to talk about today is about how model-based testing and using collaborative modeling techniques can help you to scale up your test automation. So if you're not familiar with model-based testing, it's kind of taking the principles of modeling in other scenarios. So think of BPMN-style diagrams, Miro diagrams that perhaps like business analysts or product owners are using, and applying that to actually, okay, well, we can map out the different application behaviors, combinations of data in a model-based format, and then use that to create our test assets. So in a nutshell, I mean, the key benefit we're talking about here is using model-based testing to let you reuse automation code. Now, what do I mean by that? Now, naturally, a model is a central repository of your information. That information could be the behaviors of your application. However, it could also be automation code. You'll see in a minute, I've got an example where we can essentially, with the model, embed that automation code and overlay it on top of the features of your application. Now, in a lot of model-based testing tools, there'll also be the ability to come through and create test scripts and test cases using mathematical algorithms. The advantage there, you can basically then optimize coverage and target different areas of your application. The key piece is you're creating a one-to-one mapping between a real-life component and a piece of automation code. If that one-to-one mapping is there, then you can reuse that piece of automation that relates to that component in any scenario or any area of the application where it might be used. Good example, somebody was talking about a login screen in one of the other talks. You can essentially have a modeled version of that login screen, and that login screen will have its associated automation code. And then whenever you use that login screen, you can trigger that code to run your tests. And then you obviously get all the collaboration aspects. A lot of the business analyst teams nowadays will literally sit in a room together and define business process flows. There's no reason why us as testers can't do exactly the same thing. That also helps to offload some of the complexity in people's heads. And in fact, if you've got business analysts who are doing modeling already, then actually taking those same concepts and applying them to testing kind of makes sense. And actually, you find that in some of the implementations I've worked on, we actually have the business analysts and the product owners at the very first stage defining our models, and then the test team comes along and goes, oh, thank you very much. That's 85, 90% of my work done. And then they can generate their tests in a much more efficient manner. So let me show you a quick walkthrough of a model and kind of what it is and how it generates some tests. So this is actually for a HRM system. We've got 4 or 5 different steps where, first of all, we're logging into the scenario. So pretty standard, right? Then we might have something called registration, edit employee, and final step. Essentially, right, it's a workflow of your application. Now, within these blocks on the screen, there's actually a whole world of complexity hidden within these. So I've just blown that up, and this one is for the adding employee, I believe. And you'll see here we've got different nodes on the model that represent different things. So some of these will be related to the automation code. Some of them will actually just be pure business logic and test steps. Now, as I mentioned, you have a lot of reusability here. So each one of your models can actually be used in any scenario. Whether you want to export them out to a PDF, BPMN, they then become these sort of collaborative pieces that you can do lots with. So on this step, we have a piece of automation code. Now, I've been using, I use Cypress on this example. But really, in the world of modeling is kind of agnostic of languages. Really, the concepts are exactly the same, no matter what type of code you use. So here we have a very boring Cypress click command with a locator in there. Now, I also mentioned creating test cases from this. So we've got in here an example where we basically generated, I think that's 146 parts there. Now, you can scale up or down on the coverage level to define how many test cases you want for a particular model. I've just edited the coverage profile. That's given me 7 parts. All of this is great, but I guess what we really want to see here is some of the automation code. So when we take a look at a whole model, we also look at all of the automation code associated with it, generate the paths, and then generate the automation. So under the covers here, we're basically pulling together all of those code snippets, whether it's Cypress, JavaScript, Java, and pushing it into an automation framework. So in this one, we just used a Git connector, chucked it out into Azure DevOps. And you'll see in a second, we've got some automation code. Now, the idea here is that, well, we're actually not now maintaining any of the automation code directly in an IDE. You're actually maintaining it from within the model itself. So I just kicked off a couple of these tests, a couple of these pass or fail, depending on which one they are. So that's kind of what modeling is. I appreciate some of you may not have heard of model-based testing before, or you might have tried it before and failed and gave up. So what I want to talk briefly about is some of the routes into modeling and show some example architecture. So this one is a super advanced use case from a company called Everfi. They basically do the onboarding training sessions that you do whenever you join a company. So in their development cycles, they have hundreds of individual reusable course components. Each one of these actually relates to a model in a model-based testing product. Whenever they're developing, their developers are essentially taking that reusable library and bringing them together into their pipeline, pushing the code, and that creates the learning management system for them. It's actually really quite impressive. Now, when they do that, they also create a JSON schema. That JSON schema gets passed into a tool that they developed themselves. Actually, it's called Modelo. That Modelo tool then converts those JSON schemas into REST API calls that can then be pushed into the model, apply then JavaScript code templates to it to automatically create end-to-end models and optimize test cases. Now, the unique thing here is that this basically all happens at the push of a button. As soon as that first step there, number 1, happens, everything else is kicked off by a pipeline. So really, if we think about it, their test cases are actually created basically automatically, depending on what code the developer has committed in a particular sprint. That really gives them the opportunity to do in-sprint test automation. The time lag between development and running the tests, is about 2 or 3 minutes, depending on how much code they've committed. So these guys set up Cypress as the automation tool, Circle CI to run it, and they also do visual testing as well, so actually create and push tests into Apply tools. Now, this is a super advanced example, and actually some of the most impressive uses of model-based testing software that we've seen. So I guess there's a couple of ways to actually get started to move to that kind of gold standard approach. So what we've got on screen here is a very traditional kind of almost waterfall kind of way of working, where you've got the features are created and refined at the beginning. Then BAs or product owners create the user story. That user story goes through refinement, picks up by dev, and then tested and released. Now, for a lot of organizations, there's a lot of technical debt, i.e. stuff that's already out there in the wild that has either been tested or has not really been tested properly. So a good way of modeling is actually beginning to re-engineer the system that already exists. The advantage of that is if you get someone who really knows the system well, and you get them sitting down and modeling that out into the different patterns and the different behaviors and the dependencies, that's when you actually, well, that's when they actually spot some of the errors that they might not have already seen. So whether that be you going to a wrong screen or a button shows incorrectly. Having it in the modeled format and as a visual flow is going to be very, very useful. So obviously that starts very late in the sprint, almost 6 months or 12 months or 18 months afterwards. And those tests will then be kind of linked back into those existing user stories that are already out there. Now, alternatively, this kind of moves us away from calling it model-based testing as to actually maybe calling it just more modeling in general. So in this scenario, we're basically saying here that instead of modeling things that are already out there, actually just model existing or user stories or requirements that are about to be picked up as part of the next iteration. What that allows you to do is actually use model-based testing tools in more of a kind of requirements or user story modeling, which you might see your BAs using BPMN tools for. And then we can go one step further and actually say, well, why, instead of just having kind of loads of written user stories, why not have the model as the requirement? The advantage there is that, well, actually, as soon as that model gets built at the very, very beginning of the workflow, it can then be used by every single persona on the way down. So whether that's your BA actually designing it, whether it's the developer using the model as kind of a reference for building the product, and then for us as testers at the end, where actually now a lot of the work has kind of already been done for us. We've got a nicely documented system in the form of a model, and then we can just overlay, if we're using Gherkin language or if we're using any particular automation frameworks, we can just apply that to an existing model. So a kind of quick adoption roadmap. So there's lots of ways to get started with modeling. We're not just restricted to one or two kind of modeling from scratch, but you can import existing work. And actually, the refinement process is going to be a very, very important step here. So thank you very much for listening. I'll hop over for any questions or discussions, but if you do want to check out any of my stuff, follow me on LinkedIn, have a look on screen there.
Thank you very much. Let's give you a huge applause. Thank you, George. I was a bit scared because I saw that you have, I don't know, 10 slides left. And how will I supposed to interrupt you? But now we are fine. So
good.
Perfect timing. Let's see the questions. Ta-da. You can read there or there. So how is it maintainable during a 2 weeks long sprint?
So it's maintainable by doing the work up front. And actually, a lot of the work you do before the sprint is the work that you can use within the sprint. So if we think back to that previous slide, we actually had people before a sprint has even started designing and refining the feature in the 2 weeks before. Once you've done that, then actually having your 2 week sprint and having those resources ready to go makes it much, much faster and much, much easier to deal with in that relatively short time period.
Let's see the next question, but maybe you can see it down there, or it's a new one. Till which test level would you recommend this technique in multi-system SV products?
So it really depends on the risk of a particular release. I think to create a huge amount of test cases for every single release is not only inefficient, but really expensive and kind of a waste of time. So I think you've got to split it up by priority. It's like the classic saying, don't boil the ocean, but actually pick your battles. And if there's one area that you think might be a checkout or a payment screen, so that's going to be more important, focusing on that rather than some of the other non-critical areas of your application.
It's so funny because I'm 44 years old, so I'm a bit old-fashioned, and the last presentation, it was a PPL, and I was like, what is PPL? I mean, they say people, thank you. So how accurate are these generated, I don't know, TCS?
Test
thank
cases.
You.
Yeah,
thank
so
you.
they...
shortening things. Oh,
sorry. Yeah, so they use a mathematical algorithm to basically figure out different paths through through your model and spit out an optimal set of test cases. If you want to actually know the exact maths, I can send you a link afterwards. But yeah, the team who build it, whenever I ask, they go, George, just trust the maths. So.
Okay, so how much time did it take from you to include model-based testing in your team, in your company?
Question. So it depends on the starting point of the team. I think if there are teams that are already doing some kind of modeling already, then you can probably start to get to the point of doing in-sprint testing in 2 or 3 months. Obviously, there's a lot of refinement to go in through that process. But I guess for brand new teams to modeling and maybe new teams to test automation in general, there's kind of a longer pickup time because, well, actually, you're not just learning how to do model-based testing, but you're also learning, okay, what's the best technology for my system? Where should I get the test data from? Those kind of things. So, I think in the best case scenario, it's probably about 2 or 3 months just to get to that fully in-sprint model-based testing.
And I think we have time for one more question. Yeah. How do you handle data in model-based testing? So,
super common way. I mean, there's a number of ways, right? You can actually use model-based testing to create your data from the model. So not just focusing on behavior of the application, but creating 50,000 rows of data from the model. The most common way, honestly, is just if you've got existing data and you've got a model that creates your tests, just kind of combine the two and say, okay, well, the automation scripts I'm getting from my model, they're just going to fetch the data from either an existing source. Could be a SQL Server, could be Excel or something like that.